In this video, we'll talk about matrix operations. So that is, once we've collected a matrix, remember that we talked about matrix as a way to keep track of all of the coefficients in a system of linear equations. Now let's talk about a matrix in a more abstract setting, and that way we can talk about how we perform operations on matrices, much like we perform operations on real numbers. And that's really what we're after. We want to be able to think of matrices or individual matrices as objects just like real numbers. And ultimately we want to turn these things into actual equations and be able to work with them in that way. Okay? So the first step is to define exactly what we mean by a matrix. So a matrix, by definition, is a rectangular array of real numbers. That's all it really is. So without context to anything else, it's just a rectangular array of real numbers. Each one of the real numbers that is in a matrix are called the entries of the matrix. And in fact, an individual matrix is defined by all of its entries, which makes sense. So we usually denote a full matrix as a capital letter. Okay, so I'm calling this matrix A, capital A. And all of its entries we usually denote by the corresponding lowercase letter. So in fact, all the entries of my matrix A are lowercase a. In particular, this A is characterized by the size. So we say that a matrix is a particular size, and it's also defined by all of its entries. So this matrix A, is defined by the number of rows and the number of columns. So M by N means the number of rows by the number of columns. Okay? So this matrix has M rows and N columns. And again, a given matrix is defined by all of its entries. So these are all of its entries. This is one way to define a matrix as a bunch of entries Aij, where for each entry Aij indicates where every one of those entries are. Okay? So in other words, Aij is the entry in the ith row and the jth column. And that way we can recall any single entry. So if I want to indicate what entry I'm talking about, I say, let's say for example, I want A12. Well, that means I want the element that's in the first row and the second column. Okay? That's what I'm talking about when I say Aij here. And in particular, that means if I write out the full extent of this matrix, which could be any size, as long as it's M rows and N columns, whatever rectangular array of numbers I want, here's how I'd label all of them, just like this. That is, for this first column, again, here's A11. That's my first entry. That is, it's in the first row and first column, therefore A11. The second entry here is in now the first row, clearly, right? The first row of the matrix, but it's in the second column. So that's why it's the first row, second column. Again, row, column. And so on and so forth. So I put a bunch of columns here, and I notice that at the very end here, the last element in the first row is going to be, again, this matrix has n columns, so therefore it's in the first row, so it's A1, and of course it depends on how many columns it has n columns, so it's element A1n. Okay, that's the entry of this matrix. And then if I go to the next row, A21 is just, you can see here, it's the element that's in the second row, okay, and first column. This is the first column right here. If I continue down this way, down the first column, you can see I just subsequently put a bunch of values in the matrix. And in the very end here, I'm still in the first column, so that's why I have a 1 here in the column spot, in the J spot, but I'm in the last row, in fact, right? So the last row of the matrix, and we said it originally that there were M rows. So if I have M rows, this entry is in the mth row, it's in the last row, but still it's in the first column. And I put all of the entries in, and of course at the very end, I have the last entry in the matrix, which is the mnth entry. Again, it's in the mth row and the nth column, so it's the very last entry. Okay, so in general, this is how I define a given matrix. Again, a matrix is defined by all of its entries, A, I, J, and they have to be labeled by exactly where they are in the matrix. And of course, we characterize a matrix by the size, m rows and n columns. Okay, so this is a general format of an n by n matrix.